Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us now begin solving this step by step. Cross-conjugation is a special type of conjugation where a conjugated system branches at a central atom such that two separate conjugated pathways share one atom but the two pathways are not conjugated with each other through that atom in the normal linear sense. In other words, a central sp2 carbon is simultaneously part of two different pi systems, but the two terminal pi systems are not directly conjugated with each other. They are conjugated only through the central atom. Step 1. Understand cross-conjugation. A cross-conjugated molecule contains a central carbon that is doubly bonded and also carries a substituent that is itself part of another pi system, creating a branched pi network where three pi bonds meet at one carbon but no single continuous conjugation path connects all three. Step 2. Analyze each option. A. CH2 is equal to CH. CH is equal to CH. CH2. This is simply 1,3-pentadiene linear conjugation. It is a normally conjugated diene, not cross-conjugated. B. CH2 is equal to CHC is equal to CH2. CH to CH3. The central carbon bears a vinyl group. CH2 is equal to CH and a vinylidene is equal to CH2 plus an ethyl group. The ethyl group is saturated, so the two pi bonds, CH2 is equal to CH and is equal to CH2, share the central sp2 carbon. However, this is actually a cumulated or cross system with only two pi bonds meeting at the central carbon along with a saturated substituent. This is closer to a simple conjugated system rather than a true cross-conjugated system because there are only two pi bond pathways meeting at the central carbon. C. CH2 is equal to CH. CH is equal to CH2. CH is equal to CH2. The central carbon here is sp3. It bears 4 single bonds, 2 vinyl groups and 2 CH connections. Since the central carbon is sp3, the two vinyl groups are not conjugated with each other at all. There is no cross-conjugation, just two isolated double bonds. D. CH2 is equal to CHC is equal to CH2. CH is equal to CH2. The central carbon is sp2 and is simultaneously involved in 3 pi systems. It is doubly bonded to CH2, 1 pi bond. It is attached to CH is equal to CH2, vinyl, extending pi system one way, and it is attached to CH2 is equal to CH, vinyl, extending pi system another way. The central carbon is part of all 3 pi bonds meeting at it. The two vinyl arms, CH2 is equal to CH and CH is equal to CH2, are each conjugated through the central carbon's double bond, is equal to CH2, but the two vinyl groups are not conjugated directly with each other, they are cross-conjugated. This is the classic definition of a cross-conjugated system, 3 pi bonds meeting at a single carbon where no single linear conjugation pathway connects all 3 terminal carbons. Step 3. Confirm answer. Option D has a central sp2 carbon bearing 3 pi bond containing groups arranged in a branched, cross-conjugated topology, which is the hallmark of cross-conjugation. Therefore, the correct answer is D. Therefore, the correct answer is option D.